to the science of dreams. Today, we are going through a journey through our solar system. The darkness descends slowly, gently, like a velvet curtain being drawn across the stage of day. As twilight deepens into true night, something magical happens above us. The sky transforms from its familiar blue into an infinite canvas of deepening indigo, and there, scattered across that vast expanse, appear the first pinpricks of light. These aren't just distant stars twinkling in the cosmic void. Among them, moving through their ancient paths, are the wandering worlds of our solar system, the planets that have captivated human imagination since our ancestors first looked up in wonder. Tonight, we embark on a journey through our solar system, but not through the cold vacuum of space in some imaginary spacecraft. Instead, we'll travel through the night sky itself, discovering how these worlds appear to us here on Earth when the sun's light fades, and the cosmic theater opens for its nightly performance. We'll learn why some planets shine brighter than the brightest stars, why others play hide and seek with the horizon, and how the simple act of looking up on a clear night connects us to worlds both familiar and impossibly alien. The night sky has been humanity's first window into the cosmos since before recorded history. Long before telescopes, before even the written word, our ancestors noticed something peculiar about certain lights in the sky. While most stars maintained their positions relative to one another, forming the familiar patterns we call constellations, a handful of bright objects moved. They wandered through the fixed stars, following mysterious paths that ancient minds struggled to comprehend. Greeks called them planetae, the wanderers, and that word survives today as planets. These ancient observers didn't know they were watching worlds. They couldn't have imagined that these moving lights were spheres of rock and gas, some small enough to hold in an imaginary hand, others so vast that 1,000 Earths could fit inside them. They didn't know that some of these wandering lights were scorched by proximity to the sun, while others froze in darkness 1,000,000,000 miles away. But what they did know, what they could observe with nothing more than patience and clear eyes, was that these objects were special. They were different, and humanity has been watching them ever since. Today, we understand so much more. We've sent robotic emissaries to every planet in our solar system. We've touched down on alien surfaces, sampled alien atmospheres, and returned images of such breathtaking beauty that they seem almost unreal. We've discovered that Mars was once wet, that Venus is a hellscape of heat and pressure, that Jupiter's great red spot is a storm larger than our entire planet, and that Saturn's rings are made of countless chunks of ice and rock, each one a tiny moon following its own orbit. Yet despite all this knowledge gathered through decades of space exploration, there's something uniquely profound about observing these worlds the old-fashioned way, by simply looking up at the night sky. When you see Jupiter with your own eyes, shining steady and bright above the horizon, you're seeing the same light that Galileo saw when he first turned his telescope skyward. In 1610, when you catch Venus blazing in the twilight, you're witnessing the same phenomenon that caused ancient peoples to worship it as a goddess. And when you spot the reddish gleam of Mars, you're looking at the same world that inspired centuries of speculation about alien civilizations. The night sky is our most ancient observatory, and the planets our oldest companions in the cosmic dance. Each one tells a story not just of its own nature, but of how we came to understand the universe we inhabit. Each planet visible in the night sky represents a triumph of human curiosity, world we've not only observed but explored, at least through our robotic ambassadors. And the best part is that you don't need expensive equipment or advanced degrees to participate in this ancient activity. The planets are there waiting to be seen by anyone with clear skies and a willingness to look up. As we journey through our solar system tonight, we'll visit each planet in turn, starting with the worlds closest to the sun and working our way outward to the frozen giants. At the edge of our cosmic neighborhood, we'll discover why some planets are easy to spot while others require patience and planning. We'll learn what makes each world unique, both in its physical nature and in how it appears to us across the vast gulf of space. And we'll explore the practical aspects of planetary observation, from the best times to look to the equipment that can enhance your viewing experience. The night sky is calling, the planets are in motion, following paths they've traced for billions of years, and we, standing here on our own small world, have the privilege of witnessing this cosmic ballet. So let's dim the lights, let our eyes adjust to the darkness, and begin our journey through the solar system at night. Mercury, the elusive messenger. If you want to observe Mercury, you'll need to become an early riser or a patient evening watcher, because Mercury is perhaps the most challenging of the naked-eye planets to spot. Named after the swift-footed Roman messenger god, Mercury races around the sun faster than any other planet in our solar system, completing one orbit in just 88 Earth days. But this swift motion comes at a price for would-be observers. Mercury never strays far from the sun in our sky, making it visible only during brief windows of time shortly after sunset or shortly before sunrise. Imagine standing at twilight, the sun just below the horizon, the sky still glowing with the last remnants of daylight. You scan the horizon in the direction where the sun has set, looking for a small, bright point of light hovering close to where day meets night. That's Mercury, appearing for perhaps an hour at most before it follows the sun below the horizon, or emerging just ahead of sunrise for an equally brief performance. Ancient astronomers knew this world well despite its shyness, and they marveled at how such a small point of light could move so dramatically against the background stars. The challenge of observing Mercury isn't just about timing. It's about the very nature of the planet's orbit. Mercury orbits the sun at an average distance of just 36 million miles, less than half of Earth's distance from our star. From Mercury's scorched surface, the sun would appear more than twice as large as it does from Earth, dominating the sky with its fierce glare. This proximity means that from our vantage point on Earth, Mercury never appears more than about 28 degrees away from the sun, a distance roughly equivalent to the width of 3 fists held at arm's length. When Mercury is visible, it doesn't look like much to the naked eye, just a bright star-like point, similar in appearance to the many stars scattered across the twilight sky. It shines with a steady light without the twinkling of true stars, a characteristic it shares with all planets. The steady glow comes from reflected sunlight bouncing off the planet's surface, while starlight flickers and dances, because it must travel through turbulent layers of Earth's atmosphere. From unimaginably greater distances, color of Mercury as seen from Earth tends toward a peachy or slightly orange tint, though this can be difficult to discern with the naked eye, especially when the planet appears low on the horizon where atmospheric distortion affects its appearance. Through a telescope, which requires careful timing to use during twilight hours, Mercury reveals another fascinating aspect of its nature. Like the moon and Venus, Mercury displays phases. Sometimes it appears as a tiny full disk, other times as a half moon or crescent, depending on its position relative to Earth and the sun. What makes Mercury so visually unremarkable is precisely what makes it so extraordinary up close. This is a world of extremes, the smallest planet in our solar system since Pluto's demotion to dwarf planet status, yet possessing a massive iron core that makes up roughly 85% of the planet's radius. No other planet in our solar system has such a disproportionately large core relative to its size. Scientists believe that Mercury may have once been much larger, perhaps suffering a catastrophic collision early in the solar system's history that stripped away much of its outer layers, leaving behind a world that is mostly wrapped in a relatively thin shell of rock. The surface of Mercury is heavily cratered, resembling our moon in many ways. Billions of years of bombardment by asteroids and comets have left their marks, creating impact basins so large they can be seen from Earth with powerful telescopes. The largest of these, Caloris Basin, stretches nearly 1,000 miles across, roughly the distance from New York to Chicago. The impact that created this enormous crater was so violent that it sent shockwaves through the entire planet, creating strange terrain on the opposite side of Mercury called weird terrain by geologists, a landscape of jumbled hills and valleys formed by the focused seismic energy of that ancient collision. But it's the temperature extremes on Mercury that truly boggle the mind. During Mercury's long day, which lasts 176 Earth days due to the planet's peculiar rotation, surface temperatures on the side facing the sun can soar to 800 degrees Fahrenheit, hot enough to melt lead in tin. Yet because Mercury has essentially no atmosphere to retain heat, nighttime temperatures plummet to nearly 300 degrees below 0 Fahrenheit. This temperature swing of over 1,000 degrees is the most extreme in the solar system. Imagine a world where you could literally watch lead puddle into liquid during the day and freeze solid at night. Mercury's lack of atmosphere is itself fascinating. The planet does have an exosphere, an incredibly thin envelope of atoms that are constantly being stripped away by the solar wind and replaced by new atoms knocked off the surface by micrometeorite impacts and solar radiation. This exosphere contains oxygen, sodium, hydrogen, helium, and potassium, but it's so tenuous that it's considered essentially a vacuum. If you could stand on Mercury's surface, the sky would be black even during the day, and you'd see stars alongside the sun if your eyes could adjust to the contrast. One of Mercury's strangest features is its ice. Yes, ice on a planet where daytime temperatures can melt metal. NASA's Messenger spacecraft, which orbited Mercury from 2011 to 2015, confirmed the presence of water ice in permanently shadowed craters near the planet's poles. These craters never receive sunlight, maintaining temperatures cold enough to preserve ice for billions of years despite the inferno raging just a few miles away on sunlit regions of the surface. For observers hoping to catch a glimpse of Mercury, the key is knowing when to look. Mercury goes through periods called elongations when it reaches its maximum angular distance from the sun as seen from Earth. There are two types: greatest eastern elongation when Mercury appears in the evening sky after sunset, and greatest western elongation when it appears in the morning sky before sunrise. During these periods, Mercury rises highest above the horizon, giving observers the best chance of spotting it. The viewing conditions for Mercury also depend on the time of year and your latitude on Earth. For Northern Hemisphere observers, the best evening views of Mercury typically occur in spring when the angle of the ecliptic, the path planets follow through the sky, is steep relative to the western horizon. The best morning views occur in autumn. For Southern Hemisphere observers, these seasons are reversed. Location matters because the angle at which Mercury appears relative to the horizon determines how much atmospheric haze you're looking through to see it. Even when conditions are favorable, Mercury requires a clear view of the horizon. Buildings, trees, or hills can easily block your view of this low-hanging planet. The best just observing sites or places with flat, unobstructed horizons like beaches, open fields, or hilltops with clear sight lines to where the sun rises or sets. And patience is essential because Mercury's appearance changes rapidly over just a few days. Miss your window and you might wait several weeks before the planet becomes visible again. Despite these challenges, there's something deeply satisfying about spotting Mercury. Perhaps it's the difficulty of the observation itself, the knowledge that you've succeeded in seeing something many people never notice. Or perhaps it's the connection to ancient astronomers who tracked this swift messenger across the skies millennia ago, using nothing but their eyes and their persistence. When you finally catch that glint of light hovering in the twilight glow, you're not just seeing a distant world, you're participating in an observational tradition that stretches back to the very dawn of astronomy. Mercury reminds us that not all celestial wonders are easily accessible. Some require effort, planning, and a willingness to wait before dawn or linger after sunset. But that's part of the magic of planetary observation. Each world presents its own challenges and rewards, and Mercury, despite being one of our nearest planetary neighbors, might just be the most challenging of all the naked-eye planets to observe. Yet for those who succeed, there's the satisfaction of knowing you've seen something special, the smallest planet in our solar system racing around the sun in perpetual extremes of heat and cold, briefly visible in the twilight sky before disappearing once again into the solar glare. Phobos orbits so close to Mars and moves so fast that it rises in the west and sets in the east. The opposite of what we're used to on Earth. It completes one orbit in just 7.5 hours, meaning it can rise and set twice in a single Martian day. Phobos is also gradually spiraling inward toward Mars due to tidal forces, and will either crash into the planet or break apart into a ring system in roughly 50 million years. Deimos, orbiting farther out, rises in the east like Earth's moon but takes over 2.5 Martian days to set, hanging in the sky for extended periods. Mars' seasons are caused by the planet's tilted axis, which is at an angle of about 25 degrees, similar to Earth's 23.5 degree tilt. This means Mars experiences seasonal changes much like Earth does with summers and winters, and the polar ice caps growing and shrinking accordingly. However, Martian seasons are longer than Earth's because Mars takes longer to orbit the sun. A Martian year lasts about 687 Earth days, so each season lasts roughly half an Earth year. From Earth, careful observers can sometimes detect these seasonal changes. Polar caps clearly grow larger in winter and smaller in summer. Additionally, the overall appearance of Mars changes with the seasons due to varying amounts of dust in the atmosphere and possibly seasonal changes in surface frost. Early astronomers mistakenly interpreted some of these changes as evidence of seasonal vegetation growth, leading to speculation about Martian life. The idea of life on Mars has captivated humanity for over a century. In the late 1800s, astronomer Giovanni Schiaparelli reported seeing straight linear features on Mars that he called canali, Italian for channels. This was mistranslated as canals, implying artificial construction, and American astronomer Percival Lowell became convinced that Mars was home to an advanced civilization that had built a planet-wide irrigation system to combat a drying world. These canals were later revealed to be optical illusions. The idea of Martians had taken root in popular culture and remains there today. Modern exploration has revealed that Mars, while not home to canal-building civilizations, is a world that was once dramatically different from what we see today. Orbiting spacecraft and surface rovers have found overwhelming evidence that liquid water once flowed on Mars. Ancient river valleys, lake beds, and even possible ocean shorelines tell the story of a warmer, wetter Mars billions of years ago. Where there was water, there might have been life, and the search for fossil evidence of ancient Martian microbes is one of the primary goals of current Mars exploration. Today, Mars is cold and dry. Average temperatures on the surface hover around minus 80 degrees Fahrenheit, though equatorial regions can warm to relatively pleasant 60 or 70 degrees during summer afternoons before plunging to minus 100 degrees at night. Any liquid water on the surface would quickly freeze or evaporate in the low pressure. However, significant amounts of water ice exist both at the poles and underground in mid-latitudes, and occasional evidence suggests that tiny amounts of very salty water might briefly flow on the surface during the warmest times of year. For naked eye observers, Mars is easy to spot once you know what to look for. During favorable oppositions, Mars appears as a brilliant reddish point rivaling the brightest stars. But even when Mars is on the far side of the Sun from Earth and at its faintest, the distinctive color gives it away. No star is quite that reddish-orange hue, though Antares, whose name literally means rival of Mars, comes close and can be confused with Mars when they appear near each other in the sky. Mars moves noticeably against the background stars from night to night. By watching over several weeks, you can see Mars creep eastward through the constellations along the ecliptic, the path followed by all the planets. Occasionally, Mars undergoes retrograde motion, appearing to reverse direction and move westward for a few weeks before resuming its eastward trek. This retrograde motion puzzled ancient astronomers, but is simply a consequence of Earth overtaking Mars in their respective orbits, creating the illusion that Mars is moving backward.